Hey, welcome back. This is 7.1 in Math 09650, and we're going to start talking about today rational expressions, which are basically just fractions, but with variables instead of numbers. And the way the book goes is they kind of lead you through the basics of fractions, but now with variables. So if you remember back when you first learned how to do fractions, first you worked with simplification issues, then you worked with maybe multiplying and dividing, and then you worked with adding and subtraction, but with like denominators, and then you worked with adding and subtraction with unlike denominators. It's going to be that same sort of progression, okay? Except now there's going to be variables in there, and there's one other small technical detail that's kind of an issue in the first section that we're going to look at today, and that's because of the variables. There's certain numbers you can't put in for a variable. In particular, you can't put in anything that would cause division by 0. Okay, so in section 1, we're going to talk about excluding, even before we get to doing anything like simplification, excluding numbers. Basically, the fact of the matter is we can't divide by 0. Okay. And we need to avoid numbers that would cause that to happen. So we'll look at a bunch of examples here. We have the expression 11 over 3x. Okay, and it's a perfectly fine expression so long as that x variable doesn't cause a 0 in the denominator when you do a substitution in for x. So how do I figure out what number? I mean, you can sit here and look at it and say, okay, if I put a 0 in there, that's going to be trouble, right? It gets more complicated later on, so what they're going to tell you to do is kind of take the denominator and set it equal to 0. You'll have an equation, and then you solve for that, right? So divide both sides by 3, and you get x is 0, and that's the restricted value, okay? So once you get your restriction on a test, I would just say put x does not equal 0. That would be kind of the answer. In the book, the way they'll do it is they'll say 11 over 3x. This expression is undefined for x equals 0. Okay, so this is kind of the technical answer, but on a test, I would understand it if you just read x cannot be 0. Okay, so let's look at a more complicated one, maybe a little harder to guess as to what this restricted number is. And we have 17 over 6x minus 30. Okay, again, you could probably guess. I'm not much for guessing. I'm more of just put it into the machine and let the machine do the work. So add 30 to both sides. So all I'm doing is taking the denominator from the expression and setting it equal to 0. Okay. Divide both sides by 6. And it looks like x cannot be 5. Okay, so this expression is not defined for x equaling 5. But I'm just going to write it like this. Okay, x can't be 5. Let's look at a harder one still. 7x minus 14 all over x squared minus 9x plus 20. And again, all you're doing is taking the denominator of the expression and setting it equal to 0. And solving it. Set each part equal to 0. And solve those. So x can't be 5 and x can't be 4. Okay. They'll try to trick you every once in a while. So this one is a tricky one. And that the denominator, literally, if there's no variable there, you don't have an issue. So, I mean, if you try to think of it as take the denominator and set it equal to 0, well, the denominator is never going to equal 0. So what do you put for your answer, right? So this thing is defined for all real numbers. Okay, so x plus 7 over 7 is defined for all real numbers. Or if you want like a shorthand way of saying that, Yeah, I don't know if there's a short way of saying it, really. Just say it works for all numbers. Well, let's define for all real numbers. I guess is what you're going to have to say. Okay, let's look at another one. It's another kind of weird one. Okay. So the issue with this is that denominator it can't be 0. Okay, it's a prime binomial. If you tried to factor it, you won't be able to, right? So if it was x squared minus 4, we could get x is 2 and x is negative 2, but here it's not going to work, right? And you can see that more clearly if you move the 4 to the other side. There's no number such that when I square it is going to equal a negative number. There's nothing I can put in there that's going to work, unless you're working with imaginary numbers, which we're not really working with in this point. We're just worried about real numbers. Okay, so is there any real number such that when I multiply it by itself, I get out a negative? And no, right? So here, this thing is going to be defined for all real numbers. Or you could just say all reals. So x squared will always be greater than or equal to 0. So x squared is always greater than or equal to 0. It's just the way it is. Okay, so hopefully that kind of gets you through those kind of exercises. What we want to do now is just work with simplifying these expressions. Okay, so simplifying rational expressions. And it basically just, it's basically like learning your fractions all over again. And for example, note back in the day, you probably had something like this, right? And you want to just simplify it. There's a couple ways you could simplify it. Some ways are not going to be advantageous in this new context. Like some people learn to divide top and bottom. So if you divide top and bottom by 3, you would get 10 all over 9, right? Which is the answer that we want. And, but this doesn't turn out to be a good way to do it. So the way we're going to be approaching simplification, so say note before, maybe you saw this. Note now, the way we want to do it is through factoring. So you could factor 30 into 3 times 10. You can factor 27 into 3 times 9. And then you can remove the common factor of 3 over 3, because 3 over 3 is the same as 1 over 1. Okay? And then, you multiply straight across. 10 times 1 is 10, or 1 times 10, and then 1 times 9 is 9. You get the same answer, right? But it's through factoring that we want these. We want to get our answers. Okay. So now, in this chapter, or in this section, the way it's going to work will be like this. So we'll have some variable expression, that's like 3, x cubed plus x squared all over x squared plus 3x plus 2. And we want to use this type of method where we're factoring and then removing the common factor from the top and the bottom, replacing it with 1s. Okay, so in the numerator, to factor that, I can factor out the GCF of x squared. I get x plus 1 left over. So on the top here, I have the x squared and the x plus 1. And the bottom, then I can factor that in the 2 binomials. Right? So it's x plus, it's like 2 and 1. And then I see I have a common factor. In the top, there's an x plus 1, and the bottom, there's an x plus 1. So you can remove those and replace them with 1s. And you'll end up with just x squared in the top, and then x plus 2 in the bottom. Okay, so that's how it's going to go. There's common mistakes that a lot of students want to then, like maybe there's an x here, and then there's an x here. But that's not going to work here, because these are factors. X plus 2 is, you kind of have to consider that as one factor. Okay, so to remove that x plus 2 in the denominator, I need an x plus 2 in the top, and there's no x plus 2's in the top, so I can't remove that. Okay, But anyways, that's what we're up against in this section. So let's dive right in and just start looking at a bunch of these. And here one of the keys I found that I try to hone in on is that you want to factor everything completely first. Factor first. And not just little factors, factor completely. Okay, so completely first. Okay. So anyways, let's dive right in. Here we have an example, 9x squared all over 6x. Okay. So you can factor this thing completely. I mean, you could reduce 9, 6. That's like 3 halves. But let's do it kind of the factoring way. So 3 times 3. X squared is x times x. I have 3 times 2 times x in the denominator. And then you see, all right, I have a 3 over 3. It's the same as 1 over 1. I have an x over x, same as 1 over 1. And then that's it, right? So what am I left with on the top? I have 3x, and the bottom I just have 2. All right, let's look at another one. So we're just going to look at a ton of examples. I hope that we get the job done. Okay, so here we have 3x minus 9 all over 6x. So in the numerator, factor that completely. I can factor a GCF of 3. I'm left with x minus 3. So on the top, I have 2 factors, the 3 and the x minus 3. And the bottom, you can factor 6 as 3 times 2. And then we have another factor of x. And then you're looking for common factors, right? So there's a 3 in the top and a 3 in the bottom. And then that's it. To get rid of that x there, I would need a factor of x in the numerator. I don't have a factor of x, I have a factor of x minus 3, which is different. So I'm kind of stuck then at that point, and so all I have to do is rewrite it. So 1 times x minus 3 is x minus 3. And downstairs I just have 2x. And you're done. There's nothing else you could do. Back when I was, before the pandemic, I would teach people to kind of put parentheses, just leave a parentheses around there so you're not even tempted to kind of cancel the x's. And the parentheses kind of tell me that's one factor right there. The x minus 3 is one kind of symbol unto itself. Okay? It's one factor. You can't remove the x part of it, okay, without having trouble. So, yeah, hopefully that makes some sense. Let's keep on moving here. So I just have, all right, so negative 21 all over 7x minus 14. And the numerator, you can factor that. If you worry about the negatives, you can factor like negative 1 times 7 times 3. And the denominator, you can factor a 7. And then you have 7 times x minus 2. So what can we do? Remove the 7's, right? And then in the numerator we have negative 3. In the denominator we have that factor x minus 2. Okay? Just kind of think of it in my brain as having a parentheses around it. It's one factor. I'll get rid of this, but we don't write the parentheses. Let's look at another. So we have 5x minus 10 all over x minus 2. So in the numerator, I can factor a 5. I have 5 times x minus 2. In the denominator, you have this one factor of this x minus 2. Okay? So we can remove those factors, replace them with 1. So we end up with 5 times 1 all over 1. 5 divided by 1 is just 5. Okay. So getting harder still, x plus 2 all over x squared minus x minus 6. The numerator is factored, so we just have this one factor of x plus 2. The denominator we can factor in the 2 binomials. So I have x plus x minus, so it's going to be 3 and 2, right? With the negative one is the 3. Then we have a factor of x plus 2 downstairs and in the numerator. So I can replace those with 1's. And I end up with just 1 in the numerator all over 1 times x minus 3, which is just the x minus 3. Okay, this next one is the video quiz. Video quiz, video quiz, video quiz. So make sure you're copying it down like I do. plus 49. Use your equal signs just like I do. So no room for creativeness when you're talking about communicating math. Sometimes you have to invent your own notation, but that's only if you're like working in new math. And this is really kind of like math history right at this point. Anyways, in the numerator, I can factor it as x and x. It looks like a perfect square trinomial. So minus, minus, and then 7, 7. I think that'll work. Downstairs, this is a difference of squares. So it's going to be 7 and 7. And then we look for common factors, right? So we have an x minus 7 in the top and bottom. And then we're just left with the factor of x minus 7 in the top and a factor of x plus 7 in the bottom. And then there's nothing more you could do. Those guys are just not the same. Okay. So that was the video quiz. Anyways, let's look at one of these cubic ones. So I have x cubed minus 125 all over x squared minus 25. So I'm going to factor completely. The bottom guy is a difference of squares. Let's get that out of the way. Okay, the top guy is a cubic. So I have the SOAP formula. If you need to, note your a and b values somewhere. So a is x, b is 5. Same sign, opposite, always positive. And we have x minus 5, and then x squared, 5x, and then 25. Okay. You can remove a factor of x minus 5. And then I just have the trinomial up top, x squared plus 5x plus 25, and then the binomial on the bottom. Okay. Nothing else you can do. Okay, they will give you ones that you're not necessarily able to even simplify, just to make sure you've been paying attention. This guy you cannot simplify. There's no common factor. Although it looks like maybe you could take out the x, that's not true. In the numerator, you just have a factor of x. In the denominator, it's one factor. It's the x plus 7. That's a factor. Okay, so there's nothing common to top and bottom. There's nothing you can do with it. It's just what it is. So I guess you would say this can't be factored or something like that. Okay. Can't or be simplified. Okay. One sort of special topic in this section is on canceling opposites. Opposites are numbers that when you add them together, they equal 0. So back in the day, you've kind of already dealt with this. What is negative 5 divided by 5? Or negative 5/5. What is that? It's just negative 1, right? And you can see if you added negative 5 plus 5, those are opposites because they equal 0. And whenever you have opposites, they will simplify to a negative 1. Okay, so what will that look like here with variables and stuff? You'll have these things, x minus 7 all over 7 minus x. Okay, x minus 7 and 7 minus x are opposites, because if you add them together, you'll get 0. Right, the 7's will cancel, the x's will cancel, you just get 0. So it has to equal negative 1, is what I'm saying from this first example. Let me convince you of that. And this is something you wouldn't normally do, but just for a matter of convincing. In the numerator, I'll factor out, I didn't want to write that, I'm sorry. I'm going to factor a negative 1 out of the numerator. Okay, so inside, you flip the signs, you get negative x plus 7. Downstairs, I have 7 minus x. Now, in this portion, you could use what's called the commutative law of addition to rewrite it as 7 minus x, or 7 plus negative x, which is just 7 minus x. And it's because 3 plus 5 is the same as 5 plus 3, right? You're going to get 8 no matter how you do it, so there it is. Okay, so what's the point? Why would I want to do this? Because now you can see, all right, there's a factor 7 minus x in the denominator. There's a factor 7 minus x in the numerator. So you're ending up with negative 1 over 1. In other words, negative 1. And just as I said, opposites simplify to negative 1. Okay? Okay, so any sort of, they're pretty easy to spot. For example, even when they're kind of more complicated, you just look to, they'll have opposite signs, right? So this factor in the numerator, 5x minus 4, and then this factor in the denominator are opposites, because you have positive 5x and then negative 5x, and then negative 4 and positive 4. Okay, so this will definitely be a matter of opposites, and that'll equal -1. Be careful, of course, this scenario where you have something maybe like x minus 7 over x plus 7 kind of looks like opposites, but they're not. They're different. There's nothing you could do there. Okay, so it kind of is what it is. Nothing to do. Nothing to see here. Right? Okay, and you can see it's because the x's don't have opposite signs. And there's nothing you can do. You can't reduce it. Okay, that's a good one. X squared minus 4 over 2 minus x. We'll get through like maybe one or two more, and then we'll go over to my math lab. Okay, the numerator is the difference of squares, so it's x minus 2 times x plus 2. The denominator, we have 2 minus x. You can see that this 2 minus x and then this x minus 2, I hope you can see that those are the opposites, right? All right, so in this kind of setting, when you're working through these types of problems, what I usually do is just kind of cross them out, or you place the top guy with a -1 and the bottom guy with a +1. So you end up with negative x plus 2 all over 1, but you don't write the all over 1, just like you don't write 5 over 1 when you mean 5. The 1 isn't there. So if you wanted to, you could write it like that, but ultimately it would be negative x plus 2, and then they probably want you to distribute, so negative x minus 2. Okay, okay, one more, then we'll hit web assign, or my math lab. I just can't get those straight. Okay, xy, so a multivariable expression, minus 2x all over 3y minus 6. Factor completely. So get the x out, I got y minus 2. Downstairs, pull the y out, or 3 out, sorry, you get y minus 2. Common factor, well, this one's a bit silly. Not really opposites, is it? So you're just at the x over 3. Okay, let's dive into WebAssign and see what's going on there, if anything. Stop that, please. Okay. So this one just looks like there's a difference of cubes on the bottom. Yeah, we'll go ahead and do it. X cubed minus 27. Okay. The numerator looks like that's a perfect square trinomial. So x minus, I'm hoping. No, it's not, because it's 18 at the here. So it's, what do we have? 6 and 3 will probably do the job. Okay. Downstairs, if you want to identify your A and B, A is x, B is 3. Okay. So I have same, opposite, always positive. X minus 3. And I have x squared plus 3x plus 9. And then you're looking for common factors. There's 1. And I'm just replacing them with 1. So that you can see that's a 1, that red slash there. So it's x minus 6 times 1, which is just x minus 6. Downstairs, 1 times x squared plus 3x plus 9. It's just x squared plus 3x plus 9. Okay, and then type it in. Usually just hit a slash, the slash button for the fraction, then go x minus 6 up top, arrow key down, x squared, the caret exponent, plus 3x plus 9. This one looks kind of crazy. 16 minus y squared all over y squared minus 4 times 2y minus 4. All right, that denominator needs to be simplified. Let's do the numerator first. That's the difference of squares. So 4 minus y, and then 4 plus y. Okay, the denominator, I need to distribute this first. I don't, they're trying to trick you into making a simplification somewhere where you can't. And no, don't be tricked. This would be y squared minus 8y plus 16. And then I think I can probably factor the denominator. Let's see, plus y. It's downstairs. That one's a perfect square trinomial, I believe. So y minus 4, y minus 4. Okay, and then I see some opposites, 4 minus y and y minus 4. So I'm going to replace that with negative 1 over 1. And then that's it. These other guys aren't opposites. The y's have the same sign. So it's going to be negative 4 plus y all over y minus 4. We can distribute that negative. I doubt it makes a difference, but there it is. And that would be our final answer. Okay. Fraction bar. The slash key is with the question mark key. It's on the question mark key. Negative 4 minus y, and then all over y minus 4. Check the answer. Okay. This one looks like you need to do some grouping. So all of the methods that you learned about factoring will apply to these sections. So I need to factor by grouping on the top. So these two guys factor out a y, you have x plus 3. These guys factor out 6, you get x plus 3. And downstairs we have two binomials, x plus, no, so 3 and 2. Numerator, we can factor out the common factor of x plus 3. You get x plus 3 times y plus 6. Downstairs I have x plus 3 times x plus 2. And clearly we can remove the factor of x plus 3. And we're just getting y plus 6 over x plus 2. Okay. Fraction bar, y plus 6 all over x plus 2. Answer. Yay. This guy looks like maybe we have a cubic issue in the denominator. Seems pretty simple. Let's see, 18x squared plus 16 plus 6x plus 2 all over 1 minus 27x cubed. Okay, so maybe we can factor the numerator. 9 and 2. I'm thinking you can't. 6 and 3. The numbers are just too big for that denominator. I mean, for the middle, to get that middle term, there's just no way you can slice it. Because every variation is just, there's nothing you can do with this. Because your number, your middle, inner and outer are always going to be bigger than 6. There's just no way around it. Yeah, so I don't think there's anything you can do. So I'm just going to rewrite it and see what happens. So fraction bar, 18x squared plus 6x plus 2 1 minus 27x cubed. No, I guess I'm not seeing it. Depressing. 6x 18 squared plus 6x plus 2. Maybe there's some way to factor it. I really don't know what they want you to do. All right, well, let's factor the bottom. I can do that at least. So a is 1, b is 3x. So we have 1, same sign, minus 3x, opposite, always positive. And then we have 1, 3x, and then 9x squared. Maybe they want you to do that, right? Who knows? Sometimes it's just... I'm not a mind reader, you know. X squared. It's not in the correct form. although your answer is not in the correct form. I think they just want me to factor out the 2 in the numerator. And really, you know. Well, come on, let me just put the stupid, there you go. 2 times x squared is 3x plus 1. Life can always be worse, you know. Nobody's trying to. Really? Then you could factor that or something. Oh, I see. So the issue was, all right, so you can factor the GCF out of the numerator. Here you get 2 times 9x squared plus 3x plus 1. And then you see it, that was a common factor I missed. So it's all over 1 minus 3x times 1 plus 3x plus 9x squared. These guys would cancel, and you'd be left with 2 over 1 minus 3x. That was embarrassing. I'm sorry. I apologize. Okay. I have removed some of these questions. So if it says this question has been removed by your instructor, you have full credit. Don't worry about it. Somebody, probably me, had already started the assignment before I had gone in there and edited the questions, because when they first hand me off these homework things, there's like 80 questions in each assignment. So what I have to do is go through and remove a bunch. And if somebody starts the homework early, then I have to kind of do it in a weird backwards way. And that's what you see here. Okay, so just skip those. Those are no big deal. Okay. Application here. So this is good if you're like maybe a nurse or something. The doctors use rational expression to determine the dosage of a drug prescription for children. And the expression A is a child's age, and D is the adult dose. Normal adult dose is 900 milligrams. So in our problem, D is 900. What dosage should a 3-year-old receive? So A is 3. And they want you to use this expression to figure that out. So DA all over A plus 12. Okay, plugging in D for 900 for D, and then 3 for A. We get this expression. So this would be 2,700, I believe, all over 15. And then we go to our calculator. Calcutron. And 2,700 divided by 15 equals 180. 180 milligrams. Good stuff. Next. Another application. Drugs injected to the patient, and the drug's concentration Y in milligrams per liter after X hours. Okay, so Y equals the drug concentration. X hours. After injection. So just trying to figure out what's going on. So the formula they give you, 6x all over x squared plus 3. Use the equation to find the drug's concentration after 3 hours. So plug in 3 for x, basically. This all over 9 plus 3, so that would be 18 all over 9 to the 12. Reduce. Type as integer or decimal. Okay, so I'm going to put that in as a decimal. 1.5 per liter. And identify the point on the equation's graph that conveys this information. See, they want an ordered pair. They just want x comma y. I don't really think you need the graph. It's just x is 3 and y is 1.5. I don't know why you would need a graph. There it is. Okay, I think that's it then. We got you through it. So next time we'll continue on with our rational expressions. In particular, we'll want to look at multiplying and dividing them. So I'll see you. Thank you for watching, and I will see you next time.